Here is an intuitive example of determining whether or not events are independent. The example is select a person at random from the campus center. Define the following events associated with that person. Event A is that the person is left-handed. Event B, the person is taller than 5'10", and the event C, the person is wearing a blue skirt. We want to consider the independence of each pair of events. So let's start out with the events A and B. So that is someone is lefty and taller than 5'10". Now, as far as I know, there is no relationship between handedness and height, and because of that, I would consider the events A and B to probably be independent events. Okay, so the next pair to look at is A and C. In this case, A is the person is left-handed. C is the event that the person is wearing a blue skirt. Is there any relationship with handedness and whether or not someone is wearing a blue skirt? Not that I know of, so I would say, at least intuitively, A and C would also be independent. Now the last one, B and C. B is the person is taller than 5'10", and C is the person is wearing a blue skirt. Let's look at this in a little more detail. What is the probability of B given C? So what is the probability that the person is taller than 5'10", given that they're wearing a blue skirt? Well, if they are wearing a blue skirt, the probability is higher that they are going to be a woman. And if they are a woman, the probability is lower than the general population that they're going to be taller than 5'10". So this is going to be less than probability of B. So in this case, these two events are dependent. Again, there's not necessarily a causality between the blue skirt and the being taller than 5'10", but the blue skirt increases the likelihood that someone is a woman, and the woman decreases the likelihood that they are taller than 5'10".